Is this size good? Good to see?
Yes, sir.
Yes, sir.
Okay, beta. We are beginning now. And up till now, actually, we have so I have deliberately built a concept of electric current, or I am trying to build a concept of electric current. So up till now, you people have seen that from my side, I have given you the concept of a cell means a source of electrical energy. So we need a source of electrical energy. We need connecting wires by the help of which we can join one terminal or one end of the source of electrical energy with an electrical appliance. People can see, please concentrate on the cursor, on the movement of the cursor. You people can so by the help of connecting wires, one end or one terminal, positively charged or negatively charged. At the present moment, I'm not trying to discuss at which end of the cell is positively charged and which end is negatively charged. But from my yesterday's lecture, the people should have a concept now that every cell, every source of electrical energy contains one terminal as a positively charged terminal, and one terminal as a negatively charged terminal. So one terminal or one endpoint of the source of electrical energy. As an example, our cell, which is present in this diagram, which is being shown in this diagram, this particular source of electrical energy, which is a cell here, contains two terminals, two endpoints. One will be positively charged and one will be negatively charged. So one endpoint or one terminal, positively charged or negatively charged, by the help of connecting wire is being connected with an electrical instrument, which is bulb here. And similarly, the second end, by the help of second connecting wire, is being connected with the other endpoint of the bulb. This is the perfect arrangement. This kind of arrangement will be called by us later on as a closed circuit. This is a closed circuit. This is a complete circuit. Most of the times we'll be using the terminologies like closed circuit, complete circuit, the circuit which is suitable for the flow of electric current. So this is an example of an electrical circuit in which a source of electrical energy is present, in which an electrical instrument or an electrical appliance is present, in which the connecting wires are being used, with which connection is being made closed between the source of electrical energy and an electrical appliance. The moment later on, we are going to draw the required examples or the required diagrams according to our syllabus of CAIE, and you people will see there that in those diagrams of closed circuits, we will definitely introduce a switch also. Switch, which can be made on or off at times. Whenever we need to pass the electrical current through the bulb, we are going to make the switch on. And whenever we need to stop the passage of electric current through an electrical appliance, we are going to make the switch off. So the moment switch will be made on, electric current starts flowing. You people need to see in this diagram that there is a particular way for the flow of electrical current, and then you need to understand it also. Today we will inshallah define the exact definition of electrical current, and also the way with which the electrons do flow. Ji beta, look at this diagram closely, and you people can clearly see that electrons are flowing in a particular manner. This particular manner is being regarded by the people of sciences. This particular manner is being regarded by the scientist people as a cycle, bicycle, chain analogy. Please try to understand this. The flow of electrons is not like this, that just suppose this is the negative terminal. Just suppose the bottom terminal of this cell Just suppose, beta, the bottom terminal of this cell is the negative terminal. Okay? This particular bottom terminal of the cell is a negative terminal of this source of electrical energy called cell. So if this particular terminal is the negative terminal of the cell, the top terminal is the positive terminal of the cell. So what happens when current flows? The electrons need to flow from the negatively charged terminal towards the positively charged terminal of the cell. Obviously, in this particular movement, they are also going to pass through the filament of the electrical bulb, due to which the electrical bulb will convert the electrical energy into light energy and the bulb glows. But I am trying to make you understand that this particular movement of electrons will not be in this manner, that an electron will come out of the negative terminal and that electron is flowing in that particular direction, and then it is going to pass through the filament, and then finally it is going to reach at that particular spot, at that particular point. Please notice it very, very, very carefully, bacha. This is an extremely important concept. Otherwise, there are 8 to 10 different concepts of physics which will become very difficult for you to understand. I am trying to make you understand. The moment I am going to switch on the circuit, listen my words carefully. The moment I am going to switch on the circuit, in the same moment of time, the electron which is present at the negative terminal comes out. But at the same time, the electron which was already present inside the copper wire is also being guided and jumps up to move to take the next spot. In this way, all the electrons, you people can see in this animation, once again I'm going to make it on, and you people can see that all the electrons which are present in this closed loop, this particular closed loop which contains the body of the cell. This particular closed loop also contains the connecting wires. This particular loop also contains the filament of the bulb, and then this connecting wire too. All these things together have formed a closed loop. So when the electrons do flow, electrons will be moving in a specific direction at all the points. This concept is called the cycle, bicycle, chain analogy. I repeat, bicycle, chain analogy. If in case of a certain bicycle, suppose the chain contains 500 different components or 500 different small parts which are together making the whole bicycle chain. You people know, if one portion or one part or one point of the bicycle chain is moving, it means all the 500 portions, all the 500 parts are also moving at the same time in the same direction. If one of the bicycle chain portion, if one of the bicycle chain's part out of those all 500 parts will be stopped, then all other 499 will also be stopped. So the electrons do flow in the formation of bicycle chain analogy. This flow is not like that. Please listen it carefully. This flow will not be like that. An electron comes out, an electron or a group of electrons comes out from the negatively charged terminal, that particular uh, electron is going to flow in this direction, is approaching towards the filament, then passes through the filament, and then from the other side of the connecting wire, and finally reach to the positively charged terminal. But you people has to notice that the moment the electron comes out, moment an electron or a group of electrons comes out of the negative terminal, at the same time, at the same moment, an electron also enter into the positive terminal. At the same time, I said at the same time, at the same moment of time, electrons are moving everywhere. All the portions, all the parts are moving everywhere. Imagine this particular group of electrons. Please look at the cursor, bacho. Imagine this particular portion or a group of electrons is a part of the bicycle chain analogy. You know, in the bicycle chain, if this particular part or this particular portion at which the cursor is present at the present moment do move, all other portions or all other parts are also going to move. So all the portions will move together. Electrons flow in this particular manner. Ji beta, any question up till now? Shabash, are you listening me?
Sir? Sir, can you please indicate the movement of the electrons with the cursor once again?
Ji beta, I'm trying to say that the moment I'm going to switch on, the circuit, means completing the circuit, switching on the circuit, electric current starts flowing. Or at the present moment, I have not introduced the definition of electric current, so I need to say the flow of electrons starts. So electron starts flowing. This particular portion where the cursor is present is representing an electron or a group of electrons. This is also representing a group of electrons. This is also representing a group of electrons. This particular portion or part is also representing a group of electrons. All these are the group of electrons which are being represented by a particular length green line in this animation. And when the electrons flow, what am I trying to say? That all those groups are flowing, all those groups are moving in the same specific direction with the same speed. Just like as when the chain of bicycle is being moved, then every portion of this particular chain is also being moving. So this is not like as, just suppose that if there are 50 students or 100 students which are sitting in a closed loop by making a circle, suppose. I repeat, please listen it carefully. Just suppose that there are 100 students sitting together in a closed loop by making a closed loop in the form of a circle or in the form of an ellipse. This particular movement is not like that. And also imagine, also suppose that every student has 8 books present in his or her hands. I said 8 books. Suppose the topmost book is the book of physics, then there is a book of chemistry, the same book of physics, the same book of chemistry, the same book of Urdu, the same book of English, and in this way they have the same sequence of books and they have the same books in their hands. Every student has a bunch of 8 books in his or her hands. When the book starts flowing, a particular student will give all those 8 books towards his right hand side to the next student. When I have focused a particular student A, suppose, when the book starts flowing, when that particular student A will give all those books to the student B sitting towards his or her right. But at the same time, the student Z, which is sitting to her left, also passing the same 8 books to student A. Student A is passing her 8 books to the student B, but at the same time also getting the same 8 books with the same sequence, with the same weight, having the same group from the student Z. So what am I trying to say? That those 8 books are present. That particular group of electrons is present at all the positions at the same time. Always. Whether those electrons are moving or those electrons are not moving. So that particular phenomena is called the bicycle chain analogy. Once again, coming towards an example of bicycle chain analogy, I am trying to say that when the electrons do flow, they flow in this manner as was shown. Look at again. If the electrons are moving in all directions. Electrons are moving everywhere. It is not possible well. This is a circuit diagram which you people need to plot over and over again. This is the circuit diagram which you people need to plot. This circuit diagram contains connecting wires. This circuit diagram contains a symbol of a lamp. The circuit diagram contains a cell. And once again, you people can see a closed loop here. A closed loop is present here in which current can be made to flow. Electrons can be made to flow when switched on. Yes. Question, bache? Any question, or should I proceed forward?
Sir, when the electrons start flowing out from the negative terminal, does the electrons in the copper wire also start flowing?
Yes, exactly. That's what I'm trying to say. Every portion of the circuit, whether that particular portion is the portion from the connecting wire, whether that particular portion is the portion from the cell, whether that particular portion is the portion from the lamp, electrical lamp, all those particular portions are behaving as a portion of the same bicycle chain. The moment the flow of electrons starts, it will be present everywhere. And the moment the flow of electrons will be stopped, it will be stopped everywhere. It is not possible that the portion or a group of electrons is still flowing inside the cell while the portion of electrons or the group of electrons which was present in the connecting wires is being stopped. Impossible. If the flow will happen, then the flow will be present everywhere. If the flow will be stopped, it will be stopped everywhere. Okay?
Okay, sir.
Yes.
Right, beta. Now we are in a position, we are in a perfect position to define what is electric current. This is the definition for which I was trying to build the background during my yesterday's or during my last 2 or 3 lectures. So now we are in a perfect position to define this definition of electric current. Yes, electric currents will be defined as a flow of charged particles, or at the present moment, the electric current can be defined as the flow of electrons. The flow of electrons or the flow of charged particles is going to be defined by us as electric current. But you people know that our definitions of physics are not that simple. We used to impose some conditions. As an example, when you people have defined speed for the very first time in the syllabus of physics, their teacher has defined that speed is actually the distance covered by the moving body. But that is not the complete definition. If you people will just write that speed is the distance covered by the moving body, examiner is not going to award you the marks at all, because speed is being defined by the people of science. Speed is being defined by the students of science as that speed is the distance covered by the moving object in 1 second. Speed is the distance covered by the moving object per unit time. So per unit time was actually the condition which was being imposed by the students, which was being imposed by the teachers, which was being imposed by the scientists, which was being decided by the team of scientists when they were defining for the very first time the definition of speed in the history of science. So we have defined that speed is the distance covered by the moving object per unit time. We have defined pressure is the force, but that particular force which is being exerted on unit area. Pressure is the force. I admit today that pressure is also a force. Yes, pressure is also a force, but this is not a complete definition. Pressure is that particular force which is being exerted on a unit area. Force per unit area is called pressure. Force per unit area is called pressure. So this is our way with which we used to define our quantities in the syllabus of physics. We were defining our quantities in the syllabus of physics. We are defining, and today we are going to define electric current in a similar manner. So electric current will be regarded as the flow of charged particles. Electric current will be regarded as the movement of charged particles, flow of electrons or flow of charged particles, but not the simple flow of electrons or the simple flow of charged particles is going to be defined by us as the definition of electric current. We are going to define that the flow of electrons or the flow of charged particles per unit time. I repeat, per unit time. As an example, if I'm going to focus at a particular point in this closed circuit, suppose this particular point at which the cursor is present. From this particular point, there is a number of charge. There is the number of electrons which are passing from this position. How many electrons are being passed from this particular point in 1 second? Those particular amount of electrons, those particular number of electrons, those particular number of charged particles are going to be named by us as electric current. So please listen it carefully. Today I'm defining electric current as the amount of charged particles, the flow of electrons or the flow of charged particles per unit time. So somebody can repeat that. What am I trying to define? Shabash, what am I trying to define? What is the definition of electric current?
It is the flow of charged particles per unit time, sir.
Per unit time, and most of the time in your syllabus per unit time means per second. So that's why at yours level examiner also accept per second. The number of charges, the flow of electrons, the flow of charged particles or the number of charged particles passing from a certain point per unit time. एक unit time में जो charge गुजरता. So what is Coulomb, beta? Now somebody has to answer me what is Coulomb. In my first lecture, I have introduced Coulomb. What is Coulomb? Okay, what is Newton?
Sir, Coulomb is a unit that...
No, I'm saying what is Newton?
So Newton is the unit that we use to measure force.
Okay. 1 or 2 years ago, you people have defined the quantity named force. Are you people with me?
Yes, sir.
So we have defined the quantity named force. Then we have defined or studied or learned its symbol capital F. Then we have studied that Newton is the SI unit, is the name of the SI unit of quantity force. And finally, its symbol was being studied by us as capital M. Similarly here, beta, today we have defined the quantity named electric current. So first of all, I want to say that electric current, a current symbol will be taken by us as capital I. I said capital I will be taken as the symbol of electric current. That in order to define that electric current equations, we need the symbols of electric charge and symbol of time also. Just like as when you people have derived the mathematical equations, speed equals to distance over time. There you need the symbols of distance, symbols of time, and then finally the symbol of speed was being introduced. So by working on the same analogy, here I can work like that. Look at that. If in time t seconds there is a body which is covering distance equals to d meters, then in 1 second of time the body will cover a distance equals to small d divided by small t. And that was being named as speed by us. That was being defined as speed by us. So that's why I have placed the symbol of equality and also the symbol of small b. So v equals to d over t was the formula, was the mathematical expression which can be used to calculate the value of speed or distance or time if out of these three variables, two are being given to you people. Similarly, in this manner, we have also somewhere derived the equation of pressure also. So today, we're working on the same principles. I'm going to define the mathematical derivation of electric current. If in t seconds of time, q coulombs of charge is passing from a point in the electric circuit. I repeat, beta, please listen it carefully. I'm trying to say, I'm teaching you that if in t seconds of time, q coulombs of charge is passing or is flowing from a certain point, from a point in the closed circuit. If in t seconds of time, q coulombs of charge is passing. Now tell me, what is Coulomb?
Coulomb is the symbol of charge.
Sir, it is the
Coulomb,
time. It is the number of times an electron passes in a closed circuit at a certain point.
Coulomb is actually the name of the SI unit of quantity electric charge. I repeat, please listen it carefully. Just like as Newton is the name, Newton is the name of the scientist also, and Newton is the name which is being used by us as the SI unit, name of the SI unit of quantity called force. Newton, what is Newton, beta? Bacho, what is Newton?
The SI unit of
Name
force.
of the SI unit, name of the SI unit of quantity called force. If you people can still remember that according to F equals to ma, the SI unit of force was kilogram into meters per second square. SI unit was kilogram into meter per second square. But this whole term of kilogram into meter per second square was being named by us as Newton for simplicity. So Newton is actually the name which is being used for the SI unit of quantity called force. Similarly, Coulomb is the name of the SI unit of quantity called electric charge. And I have also taught you people that if 6.2 million means 6.2 into 10 raised to the power 18 electrons approximately are being accumulated on a certain object as extra electron, comes on a certain object as extra electrons. So we used to say that that particular object contains 1 coulomb of negative charge. While if 6.25 or approximately 6.25 into 10 raised to the power 18 means 6.2 million electrons left some substance, we used to say that that particular substance do contain a charge of 1 coulomb, which is a positive charge. So Coulomb is a large unit, is a very large unit, which is being formed by the movement of, which is being formed by the accumulation of, which is being formed when 6.25 million electrons do leave a substance or are being occupied or comes to the substance as extra electrons. So beta, overall, by summarizing this discussion, G.
Can you please repeat the part about coulombs again?
Beta, I said Coulomb, I'm just trying to summarize it now, that Coulomb is actually, Coulomb is being used, Coulomb was being used by us actually as the name of the SI unit of quantity called electric charge. Coming towards the definition of electric current, if in t seconds of time, q coulombs of charge is flowing, is passing from a certain point in a closed circuit, then in 1 seconds of time, the charge which is passing or flowing from the same point of closed circuit can be calculated by dividing capital Q with small t. So this capital Q divided by small t is being named by us as electric current. So I have equated it to capital I. Capital I will be the symbol which is going to be used by us for the representation of electric current. So finally, I have reached to the definition of electric current, I equals to Q over T. Now somebody needs to repeat this definition in English language and then translate from English language into mathematical language. As I have already told you people that languages can be translated into each other. We can translate, or we have translated so many times in our studies of physics from mathematics to English, and so many times from English to mathematics. So once again, today, first of all, we have defined the term electric current in English language. And then we have translated that English language into mathematical language or mathematical expression. Somebody needs to recall it, somebody needs to repeat it. Shabash, come on, who is going to repeat it? Shabash, what is electric current?
If in 1
What?
second of time a certain number of coulombs of charge are passing from an electrical from a point in an closed electrical circuit, then electric current is the number of charge of coulombs passing through an electrical circuit in 1 second.
A very good attempt, beta, but just recall, first of all, we have defined speed by saying that speed is the distance covered per unit time. Okay. Then we have tried to translate from English into mathematics by saying that if in t seconds of time, a certain moving object is covering d meters of distance, then in 1 seconds of time, the same object is covering d divided by t meters of distance. And that d divided by t meters of distance was being named by the people of science as the speed. So we have equated it equals to small v. So in a similar manner, I need first of all the definition of electric current, and then onwards, how have we obtained the mathematical expression. So first, the definition of electric current.
The electric current.
Electric current is the flow of electric charges
Per unit time.
Per unit time. Flow of electrons per unit time. Flow of electric charge per unit time. Okay? And how have you obtained the mathematical expression?
So if in t seconds of time, q coulomb of charge is flowing at a certain point in the circuit, then in 1 second of time, the charge flowing from the same point in the circuit can be calculated by dividing q by t.
Shabash, beta. Very good. Very good explanation. Q divided by T, and Q divided by T is being defined by us as electric current, and the symbol for electric current will be used as capital I. So we have obtained I equals to Q over T, just like as some 2 years ago we have obtained V equals to D over T. We have obtained pressure small p equals to F over A. Similarly, we have obtained today I equals to Q over T, or Q equals to IT by cross multiplying it. If I ask you, how can we obtain the SI unit of I? What do you do?
Sir, we'll take the unit of the coulomb and of the second.
Shabash. We will consider the equation I equals to Q over T. In the numerator, we have capital Q means electric charge. We are going to place Coulomb in place of capital Q, or the symbol of Coulomb, capital C. In the denominator, we have time. So we can place the second or small s in the denominator. So Coulomb per second will be the SI unit of electric current. And you know, most of the times we are going to name it something else. So similarly, Coulomb per second is being named as ampere. Ampere is the name of the scientist once again, just like as Newton was the name of the scientist. Beta, in case of speed equals to distance over time, we have derived the SI unit of speed as meter per second. And no new name for meter per second because it was not required. So speed's SI unit was meter per second. In case of force, F equals to ma, the SI unit of force was being derived by the help of a mathematical expression as kilogram into meter per second square. And kilogram into meter per second square was being named by us as Newton, a new name. In case of pressure, P equals to F over A, the SI unit of pressure, small p, was being derived as Newton per meter square. And Newton per meter square was being named by us as Pascal. So sometimes we name, sometimes we don't. So here we are naming Coulomb per second as
Ampere.
ampere, and ampere's symbol will be taken as capital A. So today we have defined the quantity, a new quantity called electric current. We have also studied its SI unit.
Sir, I have a question.
जी पूछिए.
Sir, why are those two SI units different of Coulomb? The Q and the C.
No, beta, no. Both two are different. Just like as okay, I can use the analogy of force here. You have the symbol capital F for force. Okay.
Yes, sir.
You have the symbol. You know, first of all, the name of the quantity. The name of the quantity is force. FORCE. Its symbol was capital
Yes.
F. It's the name of the SI
Yes.
unit was Newton, and its symbol was capital N. Similarly here,
Oh,
the name of the
yes.
electric quantity is electric charge. The name of the quantity is electric charge. Its symbol was capital Q. The name of the SI unit was Coulomb, and its symbol is capital C. So you people can clearly see that in case of almost every quantity, we are dealing with four different concepts. These four concepts are name of the quantity, symbol of the name of the quantity, name of the SI unit, symbol of the name of the SI unit. Okay?
Okay, sir.
Are you people with me? Are you on the same page with me, Bacho?
Yes, sir.
Yes.
Shabash, shabash. In this particular diagram, I have shown a closed circuit. These all operators, this whole apparatus which is being shown in this diagram is also available in our physics lab. So whenever we'll get a chance to move to our physics lab, inshallah, I'll show you such kind of closed loop in which a battery is present. Beta, look at that. The word battery is being used, not a word cell is being used. What is the difference between cell and a battery? That battery do contain more than one cells. Minimum two cells together. Minimum two cells together are being placed in sequence, in a certain sequence. There are two types of sequences also, but these two types of sequences are not going to be discussed by me today. I will definitely discuss those two types of sequences with which the cells can be arranged later on. But at the present moment, I'm simply trying to say that if two or more than two cells are being used, we are going to name that particular source of electrical energy as battery. Okay? I repeat, one single cell, will be called a cell by us as a source of electrical energy. But if two cells together are being used, if three cells are being used, if four cells are being used, then we are going to name that particular source of electrical energy as battery. So this is a battery, and you people can see that like all other sources of electrical energy, it does have one terminal mentioned as a positive terminal of the battery, and one terminal is being mentioned as a negative terminal of the battery. This particular terminal is the positive terminal of the battery. This particular terminal is the negative terminal of the battery. Usually, positive terminal is being marked by a red color, and the negative terminal is being marked by a black color. But it is not necessary in practical life. But usually, in our syllabus, your examiner used to use the red color for this end and black color for this particular end. So this is the positive terminal of the battery, and this is the negative terminal of the battery. Then a connecting wire is being used. One end of the connecting wire, of the copper wire, is being connected with this negative terminal. From here, I have taken that negative terminal to an apparatus, to a kind of a box, which is being seen by you people for the very first time. Whenever we'll be in school, I'll show you the variety of different ammeters. This particular apparatus, this particular box, which is being shown in this diagram, is called an ammeter. We call it ammeter. And later on, I'll show that this is being used in order to measure the value of electric current. Yes, the value of electric current. At the present moment, I can show you that one end of the battery is being connected with the one end of the ammeter. Whenever I'll show you an ammeter, or wherever people will see an ammeter, you people will notice that there are two different terminals present in the ammeter. One terminal in which, or inside of which, a copper wire can be fixed, copper wire can be screwed, will be of red color, and other one will be of blue color. I repeat, beta, ammeter is being defined, will be being defined by us as an instrument which can measure the value of electric current. Whenever you people will see an ammeter, there are so many different varieties of ammeters. You people will find that it does have the two terminals present in it. One is of red color and one is of black color. Here, this particular terminal is of red color. This particular terminal is of black color. Then another connecting wire is being taken from an ammeter, and this particular connecting wire is further advancing to a resistor, to a variable resistor, to a rheostat. One by one, we are going to define all these terminologies later on in our syllabus. I'm going to define what is resistor. Then I'm going to define what is variable resistor. Then I'm going to define what is rheostat. So at the present
Excuse me,
moment, you
sir?
don't need to bother. Gee. Yes?
The connecting wire that comes out of the black terminal of the ammeter, is it turned into a coil of wire, or is it joined to a coil of wire?
The coil of wire is not necessary here, beta. Only a wire is required. This particular wire can be of the shape of the coil, cannot be of the shape of the coil.
Okay.
Okay. Acha. In place of variable resistor, you people can also imagine an electric lamp. You people can also imagine an electric lamp. An electric lamp is present here. If at the present moment it is difficult for you to visualize a resistor, to understand the word resistor or the variable resistor or the rheostat, so you people can ignore all these terms: resistor, variable resistor, rheostat. You can consider that this is an electric lamp. Okay? Bacho, is it okay?
Sir, can you repeat
Yes,
that point again?
Yes, sir.
I'm saying that in this closed loop of electric circuit, battery is present, ammeter is present, and an electric lamp. Imagine electric lamp is present here. Okay? Now, if we want to measure the value of electric current, then that's why we have introduced an ammeter inside the circuit. in order to measure the value of electric current, that how many amperes of electric current is flowing, how many coulombs of electric charge per second is flowing in the circuit. Now somebody has to answer me, this value of electric current will be different at this point and at this point, or will it be same at this point, at this point, at this point?
Sir, it would be same in everywhere.
How do you know, beta? Your answer is correct. How do you know that it will be same everywhere? But how have you imagined it? How have you guessed your answer as a correct answer?
Sir, as you told it, bicycle analogy that everywhere.
Shabash, beta. Shabash, shabash. I'm proud of you, my child. Very good. You people have grasped this concept on a very first day. I'm very delighted on that. Yes, because of the cycle chain analogy, the very first concept which is being built on that foundation of cycle chain analogy, that the value of electric current will be same at that point, at that point, at that point, at all the points of the circuit. Means same amount of coulombs per second are passing from every point of the circuit. If 2 coulombs per second are passing from this point, then 2 coulombs per second are also passing from this point. Then 2 coulombs per second are also passing from this point. And 2 coulombs per second means 2 ampere. So this amount of 2 amperes of current can be measured by the help of this ammeter. When this ammeter is introduced in the circuit, its needle will be deflected in the right direction, or it needs to be deflected in the right direction. It is going to indicate the value of 2 ampere. You people can see from the screen that this ammeter is of the range of 0 to 5 ampere current. Ammeters will be of different ranges. The ammeter which is being used by me in this example is of the range of 0 to 5 amperes. So it can only measure the value of electric current from 0 to 5 amperes. So if suppose the amount of electric current is 2 ampere, in our case, the needle will be deflected towards right and it will go at 2. Ji beta.
सर ये बाइसिकल एनालॉजी इसलिए यहाँ लगेगी क्योंकि यहाँ पे ब्रेक नहीं हो रहा इसलिए
जी बेटा क्या नहीं हो रहा
सर यहाँ पे बाइसिकल एनालॉजी कैसे लगेगी यानी क्योंकि यहाँ पे ब्रेक जो आपने कहा था कि इलेक्ट्रॉन्स वो नहीं होते इसलिए
बेटा if a child is correct that child has to think the flow of electric current as a bicycle chain analogy, means the same group of electron per second which are passing from this point are also being passing from this point too. Otherwise, the wrong concept is the child used to think or sometimes build this wrong concept in their mind that electrons which are being emitted out from this particular point are going to flow, have reached at that particular point. So at that particular point, the value of electric current is non-zero, while the electrons still have not reached to this point. So they do have some other value at that particular point. That was what was I trying to say. G.
Sir?
G.
Sir, can you please tell the definition of ampere?